This is the circle theorem number 6. This theorem is about when two chords cross each other. You can see in the diagram here I've got two chords, one EB and one DC, and they intersect at the point F. So the purple chord and the green chord. And this theorem here relates to the lengths of the chords when they're split. So the green chord here is split into two segments, C to F and then F to D, and the purple chord split into two segments, E to F, then F to B. So if I show the lengths of the segments, nothing special there. We don't notice anything that stands out in the numbers about there. So if I move one of the points around the circle, here I'm moving E, you can see that as I move the points around the circle, the line segments change. This theorem of course doesn't work like this because the lines aren't intersecting, so it has to have the two chords have to intersect. Alright, so nothing stands out when we stop at any particular point and see any values. If we actually manage to make them go through, make the point of intersection at the centre, then that's the only time we'll notice something there, that all those segments now are the radius of the circle. But when I move away from the centre, no special property stands out there about the values there. But there is a property of these intersecting chords. If I look at the calculation here, and if I look at EF times FB, so this length times this length comes out to this number, then the product of the other two segments of the green segment comes out to the same number. So now when I move the points around, so you'll see that the calculation values do change because the lengths change, but the actual answers remain the same. So the theorem in fact is the product of the two segments of the intersecting chords of the two segments from the one chord intersecting the segment of the other chord, the products will be equal. Product meaning when you multiply the two numbers together. Let's go to the work booklet. Our last one in the booklet here says the products of the intercepts on intersecting chords are equal. So here we're asked, classic problem here, we're asked to find the length of X. We've got the chord AB intersects with the chord PQ. So probably best thing we'd do to mark the intercept point as E. So if we put the point E in at this just here, and what we would next write is this, that the product of PE times QE will be equal to AE times BE, and AE is actually the length that we need to find. So substitute those with the numbers and the letter X and right spots. So 12 times 18, the two numbers in one segment multiplied together, equals the two lengths of the other chord multiplied together. So 12 times 18 equals 8 times X, so that becomes 216 equals X times 8, so we divide both sides by 8, and when we do that we get X is equal to 27. Thank you.